Well, good morning, good afternoon, good evening to wherever you may be, somewhere across this world. Thanks so much for joining us live here today for Serverless Office Hours. We're streaming live on the AWS Twitch channel and also via YouTube on Serverless Land and also via LinkedIn Live. Super happy to be talking a bit on the container side today. So I have three super experts and myself today. We're going to be talking about some super cool integrations. Welcome Michael Gasch, who's a product manager for Amazon EventBridge. I met Michael literally on his first day at Amazon. It was at EDA Day in London. Talk about a baptism of fire. Michael, how have you come into Amazon and AWS, and what's your interest with EventBridge, other than being the PM, obviously?
Yeah, actually, it was EventBridge that brought me in. So before AWS, I was working at VMware. I had a great time there. But I already was working on a couple of event-driven systems, and one was integrating with EventBridge. And so I got to know and meet the EventBridge team, and I was excited about EventBridge and the capabilities, and in general about EDA, like event-driven architectures. And so I was convinced this is the right thing to do.
Cool. Well, awesome to have you. Yeah, I did a lot of VMware stuff back in the day. So yeah, super keen to see all how these things and how these people all come together. So we've got an EventBridge product manager speaking on the product manager side, who's actually from the Kubernetes side of our house, Mike Stefaniak. Hi there, Mike. I know you're based in Seattle. I know you've been at AWS, is it nearly 4 years, I seem to remember, and you're the PM for EKS.
Yes, I've been with AWS almost 4 years now on EKS the whole time. Although it says on the screen, actually, we're part of the AWS Kubernetes org, because what we do in EKS is much more than just the managed service of managing Kubernetes. There's a whole bunch of open source projects that we work on, one of which we'll get into today. Sometimes as the PM of EKS, it feels like you're the product manager of half of the CNCF, just given all of the different the velocity of changes going on in that community. It's great to be here.
Yeah, I can imagine Kubernetes, the whole point of Kubernetes is integrated with absolutely everything. So yeah, the integration, I can sure lands on your shoulders. So, well, thanks for joining us. And Amine, who's a software engineer, is part of also Mike's bigger product org. And I was just chatting to Amine before we left. He's actually from Luxembourg, but he's at KubeCon in Amsterdam, and actually drove through Luxembourg on Sunday, which was on a beautiful day. So Amine, welcome to Serverless Office Hours. What's your sort of involvement on the whole Kubernetes side?
Nice. Thank you for having me. So on my side, I've been doing Kubernetes for maybe 5 years right now, and joined AKS maybe 2 years. So I'm mostly working on AKS, a little bit of open source, ACK, a few things here and there. So yeah, staying with the container side.
Excellent. Well, thanks to have you. We're just quickly going to look over the past week of serverless before we get on to some cool Kubernetes stuff. Last week on the stream, building Java apps with SAM. So Mehmet, Stephen, and Maximilian were chatting to Eric all about how you can use SAM and all the cool tooling that's done to do with building Java apps. And that's available on the Serverless Land YouTube channel, along with all the other previous episodes. Just with what's new, just on the sort of serverless side of the house, if you're a Lambda customer, well, today I'm sure you're going to be super happy. Lambda Python 3.10 is now available, so that'll be super good. Just jumping down 3 to the other Lambda one, which is Lambda introduces response payload streaming. So if you want to get incremental updates from your Lambda functions, that's it. And somebody I know wrote a blog post about that. We'll show you shortly. And Amazon S3 is coming out with some new things, and AppSync can amplify as well. So the QR code and that link just takes you directly to all the what's new kind of things. In terms of the serverless blogs, well, there are a lot of blogs people write to talk about some of these announcements and things. So Python 3.10 and the Lambda response streaming. And then also the serverless, in case you missed it, blog post I put together, which is literally all the things in the serverless world over Q1 2023. And putting that together, you sort of realize how much is going on, how many releases and interesting blog posts and videos and articles and that. So that's your sort of one-stop shop to catch up on what has been going on. But obviously, we're in the containers world as well. So this was just a quick grab from what's new kind of thing. Not to put you on the spot, but are there any sort of quick jump outs that any of you want to talk about that looks interesting you'd like to highlight?
Well, I think that a couple ACK controllers are mentioned there, which we'll cover in detail today. And then a lot of the work we do is making sure Kubernetes integrates with other AWS services. We want to give the power of AWS to Kubernetes users. So ACK is a good example of that, but other examples that I see on the screen is GuardDuty. We worked closely with GuardDuty to make sure that they supported containers and monitoring those well.
Okay, excellent. Thanks, Mike. So yeah, well, let's jump into the whole kind of premise of today, which you're talking about is managing EventBridge with Kubernetes. And I know some people will be thinking, "Hang on, Kubernetes serverless, what is all this kind of thing?" And I know, Mike, you mentioned the ACK part. So yeah, I don't know who wants to kick off. I know, I mean, you've got some slides to share with us as well. But yeah, let's talk about managing EventBridge with Kubernetes, and where does Kubernetes end and where does EventBridge start, and vice versa.
Yeah, so I think we'll start. Given this is the serverless channel.
Just before kicking you off, just remember we are live, so send us your questions and your comments or via the chat on the various kind of things. Please, we're here to answer your questions and find out what we can help you with. So yeah, please let us know in the chat. Sorry, Mike, I interrupted you literally on word 3, which was rude of me, but we want to make sure that people get their questions in.
All good. Yeah, so this is the serverless channel. Not everybody might be familiar with Kubernetes, so we're going to give just a quick overview of Kubernetes, and we'll get into ACK and how you can use Kubernetes together with EventBridge. So what is Kubernetes? I think I looked it up before this session. I think it's been almost 10 years since the first public commit of Kubernetes. It was back in 2014, and maybe even before Kubernetes, to talk about containers. Containers solved that classic problem everybody's heard about, where it worked on my machine, but then I deployed to prod and it didn't work. And containers solve that problem by allowing you to package up your code along with your dependencies. But that solved one problem, but it introduced others. Instead of a couple of VMs to deploy our applications, now you may have hundreds of containers. And you run into a new challenge of, how do I scale those containers? How do I patch them? How do I monitor their health? How do I do all of that at scale? And so that's where container orchestrators came in. And there were a couple of them, actually many of them that launched. AWS also has Elastic Container Service, ECS, which is our native version. But in the open source, Kubernetes emerged as the winner of container management at scale. And there's a lot of reasons why users say they manage containers, or they've moved to Kubernetes. Some of the classic examples you see are, well, it's portability. I can run Kubernetes across lots of environments, or it's scalability, efficiency, and those are all reasons. But one of the more common, probably the most common one that we see from talking to EKS customers, and if you look at CNCF surveys, it's really about the speed of deployment and the safety of deployment that you get with Kubernetes. So it's about being able to deploy your applications more often and more safely. And it's really because of the declarative reconciling model that Kubernetes came with, where you tell Kubernetes what you want the end state to be, and it has essentially robots, controllers, that are going and making that state happen. So humans are much more out of the loop than they used to be, and Kubernetes will only surface issues if it detects something where a human has to come get involved. So container orchestrator is what Kubernetes started as. But I actually think a better definition of Kubernetes is a well-designed and extensible API that's declarative and self-reconciling that happens to come with a container orchestrator built in. And that's where really you start to get about the one of the more powerful aspects of Kubernetes is custom resource definitions, which allow you to extend the Kubernetes API to anything you want to do. So yes, there's a container orchestrator that comes out of the box, but with the CRD capabilities, you can do whatever you want. You can build an API for anything, and that's one of the really powerful features of Kubernetes, and one that's being used more and more by customers today. And that's where ACK comes into play.
Yeah, so I mean I think that's a really sort of interesting concept, that people do think about Kubernetes and the whole Docker movement and everything is about the container orchestration from the actual compute and maybe some of the networking and all that kind of things to get the containers up and running and manage them. But the API as a standard API that then you can use along a whole different raft of things, and that means you can manage a whole bunch of AWS resources using the Kubernetes API rather than having to learn the AWS API. Specifically. And I know, one of our internal people, Massimo Rafferro, who is awesome from Italy, he wrote a blog post on, the difference between Kubernetes as a platform versus Kubernetes as an API, which I will put up on the screen. And it's a really good way, I think, to think about these two different parts of it, the actual container orchestration and then managing containers via the Kubernetes API. So yeah, certainly have a read of that. I found that super useful.
Yeah, I actually worked really closely with Massimo on that blog, and I'm actually the anonymous quote in the blog that says what a better definition of Kubernetes is. So
cool.
Well,
Mr. Anonymous, you've now been outed as Mike.
Yeah. Yeah, maybe before we... Oh, go ahead, Michael.
Yeah, I just had one comment on Kubernetes because, I work on the EventBridge side, which is a serverless service, right? And I get a lot of questions of why people want to deal, or developers want to deal with Kubernetes and low-level things like containers and all this stuff. And so prior to joining AWS, as I said, I was working for VMware, which, is a company that got popular for virtual machines, right? Basically going from hardware to virtual machines. And I compare Kubernetes, the evolution there, and what the developers did, exactly the same as like what we did with hardware to virtual machines. And it's very natural for people, for developers, to go like more progressively from a state where they manage virtual machines and then they manage or package containers, versus like a new model, a new abstraction, which is on the serverless side. And to me, both worlds, like managing containers and serverless, they are like two sides of the same coin. But it's for a lot of developers, it's a huge leap to embrace the serverless mindset and the new tooling and the way of thinking. And so sometimes they are kind of, quote, afraid of embracing these new tools. And they're just, I want to use the things that I'm familiar with. And I get a container to them, it's often feels more natural and familiar from an evolutionary perspective. And also the tooling to build like local stuff, local testing, local running this stuff locally. Kubernetes has awesome support for that. And so that is something I think a lot of people might miss if you've dealt and worked a lot with serverless platforms, that you kind of lose this mentality of the other side of like the evolutionary approach. And, that's where I think there's no right or wrong on both sides. Whether you use Kubernetes or serverless.
Yeah, Mike, that's an important point of the distinction between what you're actually running and the actual tooling that you use to create these kind of things. And that's part of the reason why Lambda came out with a container image support, because the container ecosystem is really built up. The tools are fantastic. The image scanning, all the CI/CD pipeline works, all the ways to different build container images. And Lambda was great in the way it does it. But if people are used to using container tooling, well, I don't want to have to learn to have another tool. So, Lambda can just now build from Docker images, OCI image spec, and I can see exactly the same sort of way of, I'm used to using the Kubernetes API for a whole bunch of different kind of things. I like the idea of serverless. I want to use Lambda. I want to use EventBridge specifically, but I don't want to have to learn this other tool, and I want to use it in my existing workflows.
Yes, exactly. Sorry, Mike.
Yeah, so I think the next slide was on EKS. We'll only cover briefly EKS here, but EKS was born when we saw an incredible amount of usage of self-managed Kubernetes on EC2. 4-5 years ago, before EKS existed, there were tons of people running Kubernetes themselves. It was clear Kubernetes had a value prop, but we also heard from those same set of customers that operating Kubernetes is not fun. Trying to do etcd, the database that backs Kubernetes, and manage that is not an enjoyable thing. It doesn't deliver value for your business for the most part. Scaling and patching the API servers, the front end of Kubernetes, again, especially when you're running at scale, not something that's necessarily fun to do. And that was a classic case of something AWS is good at, which is taking something, doing the heavy lifting. We manage etcd for you. We scale your API servers. We patch them. You get to use Kubernetes without having to become an expert in operating Kubernetes, and that's really what EKS does for you. So at this point, the amount of self-managed Kubernetes left on AWS is pretty small. Most people have moved to EKS because it just makes your life easier for you. And yeah, if you're not familiar with Kubernetes, I talked about the declarative nature of the API, the Kubernetes resource model. So here's an example. Typically the lowest level abstraction Kubernetes in pod, which is a group of containers. And then there's various controllers on top of pod. So a deployment is if you want to say, I want 5 replicas of this Nginx pod to be running at every time, you do that. And it's a declarative API. So you apply this to Kubernetes, and then Kubernetes has controllers that act on these specs and go make it happen. So it's not a CRUD API where you're saying create, deployment, update. You're saying apply. This is my end state. Kubernetes, go make it happen. So this gets us into ACK. And when I talked about Kubernetes earlier, there's a few different ways and ways that people use Kubernetes out there. On the one extreme end, yeah, you can leave this slide up. On one extreme end, there's people who want to run all of their software within the Kubernetes cluster. So in addition to their typical, stateless web applications, they're also going to run their databases inside Kubernetes. They're going to run their message queues, their caches. They're going to run everything inside Kubernetes. More typically, what we see is customers were running their stateless applications in Kubernetes, but then they wanted to leverage AWS managed services for other parts. So again, running a database inside Kubernetes, you can do it, but not necessarily recommended. It's better to use a managed service like RDS, or you could run a cache or a message queue inside Kubernetes, but probably better to use something like Kinesis. And customers were doing that, but it was hard to connect the dots. You'd have to, especially for developers who are familiar with the Kubernetes API, that's what they're using to deploy their applications. They'd have to open a ticket to some team that says, hey, can you go provision an S3 bucket or provision a DynamoDB or an RDS database? And then they have to get the connection URL. People are sending around environment strings over Slack, and eventually it's making into a Kubernetes manifest. And that is just not a friendly workflow for developers. So ACK came about and we said, what could we do to make it easier for developers to leverage the power of AWS managed services, but from within the familiar Kubernetes API that they're used to? And so ACK takes advantage of the Kubernetes custom resource definition model, where every AWS service is modeled as a custom resource definition in Kubernetes. So now as a developer, you can define your application alongside your supporting resources like the S3 bucket, the Dynamo table. You deploy that to the cluster, and ACK controller is going to see that you've requested an S3 bucket, a Dynamo table. It's going to go provision it. You can export the connection info to a config map or a secret and directly consume that in your application. So the main target persona use case for ACK was simplifying the lives of developers who want to take advantage of AWS managed services rather than trying to run databases or message queues themselves inside the cluster.
Mike, just something I know some people think about when you're using an API to provision things and manage things, but people then are also thinking about infrastructure as code. So there's obviously the whole, CloudFormation or Terraform or Pulumi or that kind of thing. How do those sort of ideas fit together, and where are they separate? Where, obviously it's good practice to encourage people to use infrastructure as code. If you're then using the Kubernetes API, does that negate that? Is it a different way of doing that for the same end state, or how should people picture that in their heads?
To me, Kubernetes, the API, is somewhat of an evolution of infrastructure as code. So we see a lot of EKS customers today who have moved to the Kubernetes API for deploying their applications, but they're still using traditional infrastructure as code like CloudFormation or Terraform to deploy their infrastructure. ACK is allows them, if they want to move to the Kubernetes resource model for both applications and infrastructure. So they're similar, but the typical infrastructure as code is not self-reconciling. Whereas when you deploy things in Kubernetes, it's always going to reconcile to to your declared state. And so it's a bit of an evolution from IAC that always make sure what you declare is that the desired state is realized, that the actual state is realized against the desired state. Whereas more traditional IAC, you're declaring it, but there's not something, it's still something you're applying if you want to make
Right.
changes.
And that's also not just for things you're running in Kubernetes, but then things you're using the Kubernetes API for the ACK controllers, that's also doing the desired state of, whatever you're doing on EventBridge, for example, in the back end.
Right. Yeah, so ACK, I kind of covered this. Every AWS service has its own ACK controller. We made this design choice for security and scalability reasons. If you had a single controller for all AWS services, then you have to give it an IAM role that has essentially AWS admin permissions, which is not necessarily secure. And you can run into scalability challenges in Kubernetes if you have lots and lots of custom resource definitions. So we took the approach of a separate controller that maps to an AWS service. And one of the more powerful under the hood features of ACK is the code generation. We knew that if each AWS service team was going to have to start from scratch to write their controller, it wasn't going to scale. So Amine and the core ACK team on EKS focuses a lot on code generation, where with a couple of CLI commands, you can get 90% of the way there on an implementation. It evaluates the AWS Go SDK for that service API, generates a bunch of the boilerplate code, and you have to write your test cases, and in some cases, if there's weird things about your API, make some changes. But for the most part, it's very easy for ACK developers to build a controller, and that was a very important point we knew that we had to get right if ACK was going to be successful. And I think maybe this is my last slide, and I'll let other people take over. But some cool features in ACK: you can manage resources across accounts and across regions. So you can have a controller running in one cluster that manages AWS resources in different accounts or different regions. You can adopt resources. We know that in a perfect world, you just start with ACK. In the real world, you have a bunch of existing infrastructure. And we have features that allow you to have ACK take over management of that. And yeah, one of the other field exports. So this was a more recent feature, but it solves that problem I was mentioning earlier where admin provisions a S3 bucket. How do you get that credential information to the actual application that needs it without passing it around or storing it in some files? With ACK, you can just export the credentials of the connection information of the AWS service into a Kubernetes config map or a secret, and then directly consume that in your application.
And similarly to pods and deployments, ACK style is very declarative, like using YAML. So you can define a kind API version and your spec, and you can see here how you declare a DynamoDB table using a Kubernetes-like manifest. Michael, want to go on EventBridge?
Yep, because the title of this presentation was EventBridge with Kubernetes, right? And not Kubernetes with Kubernetes, but just joking. So far, we've talked a lot about like the infrastructure and the stuff that runs your code. But eventually, you as a developer, you do want to write code and build applications, right, and logic. And so this is where EventBridge comes into the picture. And so briefly, what is EventBridge? EventBridge is a cloud service, like serverless AWS service, which allows you to build event-driven architectures and applications more easily. As a serverless service, obviously, it is there to reduce costs and accelerate time to market with building event-driven architectures where you assemble basically your architecture with loosely coupled components instead of figuring them and wiring all them together in like more traditional APIs. And so this gives a lot of autonomy to teams where they can react to changes in the system that EventBridge lets you know about with like these events that flow through the system, and also allows for scalability because you can trigger off different actors like a Lambda function, or you can send an event to a queue or to an SNS topic, etc. And so this service really scales and makes your application architecture more resilient and also scalable as well. Next slide, please. And so EventBridge, it started as an event bus, an event broker, if you will. But over time, EventBridge also has evolved into a suite or like a framework for building event-driven applications. And so we'll talk about event buses and pipes today. Event buses you can think of as like these aggregators, these brokers from multiple sources to multiple targets, letting you route these events from these different systems, between these different systems. Pipes is a service that we announced last year and released last year at reInvent, which lets you build point-to-point integrations similar to the Unix pipe. That's why actually the name pipe was used there, where you have a source and a target and you directly want to wire them together. And lastly, scheduler is also a feature that was announced last year. And this lets you set up schedules where you want to be reminded of a specific task or event, and then the scheduler will handle all these schedules at millions and scale for you. But for ACK, what we did is we built a controller for EventBridge, event buses, and pipes. Sorry, Amine. Yeah, please go ahead. And so briefly, because the demos that Amine is going to show, we'll talk a little bit about some of the EventBridge components, and so everyone can follow here, especially if you're new to EventBridge. So on the left side, EventBridge has the concept of these sources, and these sources can be AWS services like S3, DynamoDB. Well, DynamoDB is then for pipes, but basically a lot of AWS services, including CloudTrail for auditing and security purposes, but also custom apps. So you can build your own event-driven applications and send your custom events or domain events to EventBridge. At the core of EventBridge is a rule service, a pattern match library, basically, which matches against very complex or simple up to very complex rules of these event schemas. Say, for example, you want to match all S3 events that come through your bus, then you set up a rule which has a detail type matching on AWS.S3. And then on the right side, we have the targets, EventBridge targets, where this is where you want to send a matching rule or a matching event to. And we support like 40 plus targets there, including webhooks and HTTP endpoints, but obviously also Lambda, Amazon SNS, and so on. So this is for EventBridge event buses. And for pipes, as I said, pipes are a point-to-point or a one-to-one concept of integrating between services. And there on the left-hand side, pipes supports the polling or streaming-based services like DynamoDB Streams, Kinesis, SQS. Pipes as well has the rule capability, the filter, the pattern matching library. And then on the right side of a pipe, the output is all the targets that EventBridge supports today. And the very common use cases for pipes are actually DynamoDB to SQS or Kinesis to SQS. And I think, Julian, you did a pipes session earlier, late last year, right, with Jeff, my colleague, on pipes. Yes. So we'll definitely share all these serverless office hours on these services. Thank you, Amine. Next one. And so before we jump into the demo, and we have two demos that we brought here, we actually looked at the common use cases that EventBridge is used for. And so a very common use case since launching pipes and a quickly growing in adoption has been, I have a DynamoDB table and I want to react to changes of a DynamoDB stream and send those specific events of these streams, like inserting an item or updating an item or even deleting an item on the table to an SQS target. Now you will notice that none of these components here are Kubernetes specific. And this goes back to what Mike said earlier. This is if you want to consume and basically build event-driven applications without actually running all the infrastructure and services required for that. So this is using the power of the ACK to project these AWS services like DynamoDB and SQS and pipes into the Kubernetes resource model so that developers familiar with Kubernetes can use the same tooling and processes to build their event-driven applications and also, troubleshoot and introspect all these services. So just briefly on the demo scenario that we have here, we have a DynamoDB table on one Kubernetes namespace. We haven't talked about Kubernetes namespaces so far, but think of a namespace as a logical construct within a Kubernetes cluster that, say, a development team owns. In that namespace, there's also an IAM role, which gives permissions to the pipe that we need to query the records from the table and then also send the events to SQS. Now, the IAM role could actually live in a different namespace or in the namespace of Team B. It doesn't really matter. This is just for us to showcase that we can manage all these required resources like IAM roles, policies, DynamoDB, etc., through Kubernetes. So you don't need to leave the Kubernetes API resource model. And then on namespace team B, we have a pipe which connects the DynamoDB stream with an SQS target queue that runs or is owned by this team B namespace. And so that is the overall application structure, very simple architecture. But if you look under the covers, what goes behind the scenes, like it's pretty like mind-blowing to see what ACK can do for you with a handful of lines of YAML code at the end of the day. I mean, stage is yours.
All right.
Cool. Just while Amine switches over, we did have a question from Brizwajit. Thanks for joining us via YouTube. How is ACK different from EKS Crossplane? With a sort of follow-up question of, well, how to decide between these two architectures?
Yeah. Crossplane is not actually an EKS project. It's an open source project from Upbound, which is a partner of AWS. They're similar. You could say CloudFormation is to Terraform as ACK is to Crossplane, like the AWS native version of something versus the third-party tool that works across multiple providers. That's a very high-level way to think about them. At a lower level, there are some architectural differences. I mentioned that ACK is a service per controller model. Crossplane took a different approach of a single controller. So you get at the expensive maybe security and scalability, it's somewhat easier to manage. So there's some different architectural choices that were made in the two projects, but we actually work quite closely with Crossplane. The Crossplane AWS provider uses some of the ACK code generation tools. So we do work together. Ultimately, ACK is the AWS owned, fully supported version of doing Kubernetes resource model management for AWS services. Crossplane is a third-party tool that isn't supported by the EKS team, but a lot of people use it as well, and it has nice features.
Cool. Thanks. So thanks for that question, Biswajit. Over to Amine. I know we want to get the demos in on time, so excited to see it.
Let's go. Are you able to see my terminal?
We can do, if we can zoom in at all, that would be helpful. Thank you for some of us
How about
without
this?
our glasses on. Yeah, that's good. We'll see.
Okay. All right. So for this demo, I'm going to be using K as an alias for kubelet. So not kubelet, sorry, kubectl. So kubectl is the command line that allows you to speak with a Kubernetes cluster. But real quick here, I'm going to show you that I'm using a kind cluster. And if I do get nodes, I have like one node. It's just a fake Kubernetes cluster running in my machine. But we're going to use that just for the demo of today. So as Michael was explaining, we have two namespaces, and I'm going to show you that here. So before we even go and create them, we can define two namespaces using the YAML file. You can see the first one here is a team A and then a team B. And in those two separate namespaces, we can create different resources. So for the first demo, we have scenario 1, and I can show you a little bit how it looks like. For example, like queue, we can define here an ACK queue that is deployed in the namespace team B, has a delay seconds of 0, and is tagged with serverless office hours. And also look at what we can have. Also, for example, some IAM definitions, or like IAM YAML files. For example, here you can define a role. You can have the assume role policy documents. You can have things like policies and everything you need to manage IAM permissions using your Kubernetes cluster. So without even worrying too much, I think I already have a table, if I'm not mistaken. No, I think it should be in a different namespace. Yeah, actually, let me show you how a resource looks like when it's deployed by ACK. For example, if I do here, show me the details of this DynamoDB table, you can see our spec. We were defining the attribute definitions, and then the key schema, the provision throughput, and the stream specification. In this specific demo, we're going to be streaming things from DynamoDB to SQS. So we needed to enable this one. And most importantly, and this is something all the ACK resources have, is a condition and ACK resource metadata. For example, here you can see the role arm of the DynamoDB table. You can see the account that was used to create it and the region where it was created. And most importantly, there is a condition saying that the resource is synced. And this means that our desired state in the YAML file matches what's in AWS. So the controller is not really working right now, but just like rather waiting for something to drift and go and correct it. So yeah, let's go and deploy the queue. I'm gonna be using kapply queue.yaml. Gonna see, let's do queues. I have a queue here. If I do also like kapply, let's do the pipe roles before deploying the role. You can do get, for example, policies. In a different namespace. So I have two policies here. One policy that allows the pipe to push messages to SQS, and one policy that allows pipe to read the DynamoDB streams. So this is why we need those two policies, and we have a role that that's the pipe will be using to do those two actions. All right, now the main actor is the pipe. So let's look at the pipe YAML file. No, sorry, this is not the
That was
pipe.
the role, yeah.
Yeah.
So when you were deploying that, I mean, you just created the SQS queue there previously. I mean, that was super quick. That's not even. It was like, really? Has it happened? So I mean, is this because it's sort of talking to the Kubernetes API using the ACK controller, which behind the scenes I presume is then using the service API. So yeah, really quick.
So it's not using, for example, CloudFormation or Cloud Control behind the scenes. It's talking directly to the service APIs, and it's almost instant.
Yeah. And I mean, so there's a funny story. So I had a colleague, she was troubleshooting a CDK deployment, which undercovers obviously uses CloudFormation, and it was using EventBridge, global endpoints, like a pretty large application architecture. And it took so long to always reconcile this that eventually she gave up and it's like, okay, I can't figure out the problem, why it keeps failing. And I was troubleshooting this through EventBridge with the ACK controller, and it took 6 seconds per iteration. And I called Amine and said, this is like blazing fast. And it took me like 5 iterations, and it was done with the troubleshooting because it was just such a breeze. And this is to your point, Julian, because we talk directly to the APIs, we reconcile much faster than typically what CloudFormation does on the covers.
So yeah, we're gonna deploy this pipe real quick, like all the other resources. And I think pipe takes few seconds more than SQS and DynamoDB. I think they're like more instant resources, but pipe takes a little bit more time, but it should be fast enough. So quickly on the spec here, we have a source, which is a DynamoDB table stream, and you can see like the ARN is here. You can see the source parameters about like DynamoDB, some batch size and maximum record stuff. And then we have a filtering criteria. So here we're telling pipe like, hey, go on and filter only the insert event. So whenever I put a new item in the DynamoDB table, that's the event you need to pick. And the other one is the target. So right now, like, hey, when you pick this insert event, send it to the ACK queue. And we have the role that we mentioned here. So the role ARN is created here. And without further talking, let's just go and apply it and pray that the demo gods are going to be smiling to us today. Okay, so let's do the pipes. You can see like the state of the pipe is creating.
Yeah, that took much longer.
Yeah.
That was frustrating.
Oh, it was
not even time to go and get a coffee. What are you doing to us, Amine?
It's already here. It's running. Took 12 seconds. It's synced. We can also look at the YAML file here. You can see like resource synced successfully and the role on. So we can go and check what's really happening behind the scenes. Or actually, we don't maybe even need to do that. We can just do some CLI. Let's do DynamoDB put item. Yeah, I was playing with this before. So let's go and put some items in DynamoDB. Let's put maybe S is 10,000 and put another DynamoDB item, let's say 11,000. And now, if everything works correctly, if I do SQS receive messages, I should see something, either new or not. And actually, yes, I'm seeing something, and I see like S is 10,000. So this is the first item I inserted, and it's already there. So pipe was very fast as well. That was like almost instant. That's very cool.
So just to recap, you have used a standard Kubernetes manifest via the ACK controller. You've created a DynamoDB table on one side. You've created an SQS queue on the other side, and then used EventBridge pipes to tie the two together. The EventBridge pipe, whenever an insert is done on DynamoDB, is going to read that. In fact, when anything comes from DynamoDB, it's going to read that only when it's an insert, so it uses the filter, and then it's going to send it to SQS. And you've deployed that all really quickly using the ACK controller. And then for testing it, you've just added something to DynamoDB, which has automatically gone through the pipe. The pipe has matched the filter, sent that to SQS, and then you're just using the normal AWS CLI commands to then read from the SQS queue and see that that sort of end-to-end has happened. Because it's happened so quickly, I just want to check that actually that's what happened, because that's a lot of cool stuff under the hood.
That's exactly what happened. So I can do, for example, here, do get tables. I can show you everything that we created since we started this demo. So we have a table here in Team A namespace, a queue in Team B, pipe in Team B, and the roles and the policies in Team B as well. So, for example, you can have a different development team maintaining a DynamoDB table definition, and a different team doing everything related to pipes and queues. And they don't really have to mess with each other resources, but you can still connect everything together behind the scenes.
That's the power of having the pod system, that you've got this, they can be separate microservices.
Yeah.
And as Amine said, no, I think it was Mike, about the field exports. So this is an important feature that ACK offers. So you saw all this, the status objects of a queue, like a queue URL, right? Or an event bus ARN, a pipe ARN. And you can use these kind of things to project them into a configuration file or a config map in Kubernetes speech, which then in your application you can read in as, for example, environment variables. And so you can dynamically assemble your applications to tell them, look, this is the queue, this is the whatever, the pipe, if you want to know it, without hard coding these values anywhere in your application code.
Yeah, so that's a sort of service discovery system, but just using the ACK to generate those resources, generate that the information from the resources.
Exactly. Cool.
Yeah. So in a nutshell, like if you want your pod to pull this SQS message, you can just tell the ACK controller hey, go pick this value that you're gonna find in status that's queue URL, and inject it in a config map, and the users can consume that as they wish behind the scenes. And you can do that for any resource. Like imagine RDS databases, you need an endpoint and maybe a password or a username and a password. You can do that using field exports without really exposing to developers what are the real values behind the scenes.
Do we have time for one more demo?
Yeah, let's hope it's gonna work as well. This one went very well. So the next one,
yep.
Let's
use this one.
Go ahead, Michael.
Yeah, exactly. So just briefly, this is a very common use case that we also picked using S3 bucket notifications. I'll just wait.
Yes.
From current slide.
Can you see?
Oh yeah. Oh, okay. I was just thinking you do the presentation mode. That's fine. That's cool. So this uses S3 bucket notifications. So for example, if an image is uploaded, a file is deleted, whatever, and then it sends these bucket notifications with the direct integration with EventBridge to the default event bus that every account has enabled in their environment. And then what we have on the default event bus, this works like an aggregator. You could even add other resources like CloudTrail or other events. And we send these events from the default bus, if they match a particular filter, which Amine will show, to another bus in the same account. And on that other bus, we also have configured an archive where we basically archive all these events which got through the system. And this is a very common use case that we see with customers going from one central bus to like a custom bus where other developers or teams can set up their rules, pattern matches, forwarding, event triggers, etc. And so that's why we wanted to show like a multi-bus topology here, also again using archiving for events and S3. Amine, I'll let you go.
All right, so we have 6 minutes, so I'm gonna real quick show you the file. So I'm gonna show you what a bucket looks like and what kind of specification we have here. So we just like have the name of the bucket in team A, and we have EventBridge notification enabled. So we want this, whatever event happens for this S3 bucket, we want it to be sent to the default EventBridge bus. So this is what's happening with this configuration here. And what else? So an event bus is very similar to the queue as well. It's all you need is a name and the namespace and few tags. And also for the archive, if I do archive.yaml, maybe more here, but you can say I'm creating my ACK archive, and actually I'm referencing the ACK bus here. The rotation date is 10. And I think this time we can do something even nicer. It's like I'm gonna go and apply all these resources at the same time, and just let the controllers.
I mean, do you want to show the rule? Do you want to show the rule as well,
yeah, sure.
Which does a little bit of the magic?
So the rule is here. We have an event bus. So everything is coming from the default bus, as Mike explained. So S3 is going to send to the default bus. And with this rule, we're taking everything from the default bus. Whenever we see an object created, we want to send that to a target. And our target is the ACK bus we're going to create very soon. And then we have a role that we give to this target. So whatever is coming into the default bus is going to go to our new bus as well. And yeah, let's see if the demo got self minor for today. Let's see. Okay, 6 resources created, and if I do get rules, EventBridge. Okay. I see that it's synced. It's true. It means that everything got created and the rule got synced as well. So I can do, actually, let's maybe check. Are you able to see my screen?
Yes, we can.
Okay, sorry about that. So here I can go and see the rule. See the rules we created today. Okay, we can see like here the ACK rule that got created. We can see that the targets, we have the bus we just created with ACK. We have the S3 bucket also created, and some monitoring here. But I think what Michael taught me today is that to see what's really happening behind the scenes, or in a fast way, we can just go and add a new target called CloudWatch. And I'm going to do this real quick here. And I'm going to send everything to ACK.
Yeah, while Amine's doing that, Michael's tip is brilliant. If you're doing anything EventBridge, you want to know where stuff is going, just add a target for CloudWatch, and it's going to be logged, and it's just going to save you so much time. So
yeah, exactly.
Quick one, use it.
So
ask me how I know.
So I have the new target here for CloudWatch to see what's happening, and to see what's really happening, I'm going to go here and upload a new file to the bucket that I just created, and I'm just uploading the rule.yaml file here. And yes, okay, succeeded. So I should be able to see something in my new CloudWatch rule, and it should be this one. So we are 1958, and we have just something that just arrived recently is this one, and we have an objects created on an S3 bucket.
Awesome.
And the name of the file is rule.yaml. So
excellent.
Well done, Amine.
2 for 2.
Yeah, no, awesome. I mean, yeah, thanks for the demos. I think the demos go by so quickly, you sort of forget all the complexity behind the scenes that AWS is abstracted from you. I mean, you are building. I love also the whole bigger concept of this, of using the Kubernetes API, which if you're a developer using Kubernetes, and love. but you can get rid of so much undifferentiated heavy lifting by using serverless services. So you don't have to run your own queuing service or your own database service or your own, object storage service. That would be even weird with S3 being so powerful. But you don't have to run these in Kubernetes. You can use native AWS services or other services anywhere elsewhere. But we're talking about native serverless services, and then manage and control them all via your API, and get your best of both worlds. Your applications running in Kubernetes, but using the power of these amazing serverless services. In the last sort of second, does anyone have anything else they need to say? Because we're sort of running out of time. I did have one question from Biswati quickly, just about any docs and everything about custom resource definitions. I'm not sure if this is actually the right docs, but it does list all the ACK controllers. So hopefully that is the rest of the kind of thing. But yeah, just before we say goodbye, next week up, we've got serverless office hours. We are talking about Lambda response streaming. Myself and product manager Matthew Grasmix will be speaking about that. Any last questions or comments? Thanks so much for all of you for coming and talking about Kubernetes and serverless and integrating them together. What a cool story.
Yeah, maybe the last pitch, if we have in the Kubernetes Slack community, there's a ECK channel. I think it's AWS-Controllers-Kates, and
perfect.
You can find us all there if you want to reach out or talk more about ACK.
Excellent. Well, thank you very much. We'll be adding the links into the stream notes as well. Give me a few minutes to sort that out. But yeah, so we'll have a whole bunch of dumping off links which you can use. But yeah, thank you very much. And yeah, have fun building serverless applications.